My name is John Davis from BT, and as soon as the slides are actually advancing, I'll be able to give you my 5-minute tour. Here we go. So, I hope you'll take those 20 seconds off the 5 minutes. So, the economics of data processing have been transformed in recent years. Colleague highlighted to me this kind of interesting way of illustrating that just a few weeks back actually. In 1980, if you wanted to store a year's worth of Twitter data, had Twitter existed at that time, you would have had to have spent about 75% of the cost of the Apollo program, because hardware storage was much more expensive in those days. In 2014, however, to store the same amount of data, instead of costing, the cost of several rockets, actually costs approximately the same as a small used car. So data processing economics has been transformed. We can store lots more of it, and in recent years we've seen the emergence of big data, large-scale parallel compute environments, Hadoop-style architectures, which enable you to relatively quickly analyze very large amounts of data. There's an increasing need to handle this increasing volume of data from all kinds of sources. Big data is previously focused, or was mainly focused up till now, on the enterprise, but there's also sensor data, social media data, call logs, all kinds of different heterogeneous data sources. So there's this big opportunity for large-scale ad hoc analytics where you can pull all the data out of a large data lake and pull out the bits you need to do your analysis to solve your particular business problem. In BT, we are currently looking at big data over several petabytes, probably into the tens of petabytes now, and we think probably a similar amount of data across the whole organisation is not actually retained currently, so that's something that we're looking at. And big data is essentially deployed where traditional IT cannot deal with the volume or the velocity, as it's sometimes called, of the amount of data that you wish to process and analyse. And we've seen the emergence of technology to address these big data requirements, increasingly scalable and commodity-based solutions. So this is a real opportunity in the enterprise to transform the economics of data, to reduce the cost of data storage while increasing the value by enabling this new level of analytics that was previously not possible. And in this way we can start to facilitate what's sometimes called the data-driven enterprise, so evidence-based data analytics to inform the enterprise of its processes and operations. So with big data comes a number of big technical challenges, of course, as well. Data discovery, how do you find all the data that's out there? I already alluded to the fact that BT doesn't currently handle all of its data in a big data scenario. Data provenance and trust, where does data come from? Which are the data sources that you trust the most? And access control, different data sets with different levels of access control for different communities. All of that needs to be dealt with when you're analysing the data. Now these aren't necessarily new issues. We saw them in the RDBMS kind of technology world. But I think big data both magnifies those challenges and provides a fresh impetus or a new opportunity to try and solve them. And today, tooling is relatively weak in those particular areas, I would argue. So that's kind of that's big data in the enterprise, if you want. I want to, in the next couple of minutes, just talk very briefly about one of my particular interests, which is the Internet of Things, and the interplay between big data and the Internet of Things. And as you're all probably aware, the Internet of Things is predicted to generate a lot of there'll be a lot of sensors sensing data from the environment. And one prediction that I saw said there'll be 50 trillion gigabytes of data on the Internet of Things by 2020. Now, whether you believe that's a specific statistic or not is not really the point, but there's no doubt that there'll be a lot of data. And then you can see a number of quotes there from commentators and analysts saying that Internet of Things data will be the next concern of the big data world. Data from the Internet of Things will be the big data world's bigger second act. Interoperability is very important on the Internet of Things, because in that kind of world you've got sensors provided by multiple players in multiple locations in different formats. So it's actually even harder than doing enterprise big data itself. It's more challenging. It brings fresh challenges. In BT, we're using the HyperCat standard for interoperability. and the URL is there, which I haven't got really time to dive into in 5 minutes. But we're interested in promoting open IoT ecosystems so that this sensor data can be moved from silos into a much more open ecosystem where people can get access from multiple data sources in order to build their applications. And we have a BT Internet of Things data hub to support this kind of open ecosystem idea. The idea there is data aggregation, pulling it together, and thereby achieving economies of scale and giving uniform access to that data. So if you're an SME or an app developer with an idea for an application, you can come to a data hub and you can get the access to the multiple different data sources that you might need through a uniform API. So one way of accessing a multiplicity of data. And in that way we want to lower the barriers to participation for people and to foster innovation and thereby maximise the value of that data. Now I'm going to finish off very, very quickly, but I couldn't come here today and not mention the CityVerve project, which is a £15 million smart city project in Greater Manchester, proudly supported by BT. We're one of the largest technical partners in the project, and it will be generating a lot of Internet of Things based data with some real big data analytics challenges, I'm quite sure. Very quickly wrapping up, there is technology now available to address big data requirements. There's this opportunity to change the economics of enterprise data. The Internet of Things changes the game somewhat because we're talking about multiple sensors owned by multiple organisations in an open ecosystem. There'll be even more data than we're currently looking at in the enterprise, much of it arriving in near real time, which brings challenges of its own. Big data and the IoT both generate challenges, amplify problems such as data discovery, provenance, data quality, data control, trust, privacy. But there's a range of issues that still need to be addressed, and we're looking forward to working on those challenges. And that was all I wanted to say.
Okay, hello. My name is Professor Alba from the University of Malaga in the south of Spain. And you will notice that my presentation is a little bit different from the rest of gentlemen here because I'm going from the academic point of view. So I will try to present fresh and maybe a global point of view to what's happening here in big data, especially with relation to smart cities, which is the domain in which I'm working. The point here is that there are lots of potential for big data. There are lots of environments for getting data and for using them. And I think that if you think about what has been happening with the internet in the last years, you will be not surprised by looking at the talking about economy, the economical sustainability and the societal sustainability. So this kind of goals means that there are lots of people, lots of technology, and lots of new developments around the city and around the big data that it is generated by the city itself. So one point here when we're going with big data and the city is to define what is a smart city. That's a big point, because we all know what a city is, but we don't know what the smart part means. So for many people, depending on where are you working and where are you coming from in your cultural life, let's say, and work life, you think of big data itself, you think on open data, depending on whether you want to share this data to all of the rest of players in the domain. You are thinking maybe in sensors or in actuators because you want to make something different in the city. For us in the academy, and especially when you're looking at something which is smart at the higher level, you think that these are just enabling technologies. They are very interesting, they are needed, but at the end, they are not getting that smart what you are doing. They are just enabling you to interact or to know more on something, but then still you are lacking something more intelligent on top of this in order to make services and make products that you can use in the city. Because the data itself is a little bit passive. It's something that you have there, but it's not acting, it's not making anything. You can make a market out of it because you can sell data, and this is very interesting for many companies. But the point is that you're looking for products and you're looking for the health and for the well-being of citizens. So if you sit in any room, a lot of data and a lot of people, nothing will happen. I mean, you need something more that is driving the data towards the people there in the city. So the point here is that not everything is clear because we have been dealing with lots of different concepts and everything is being created right now. So the city is very clear, the smart part is not so clear. We need to define it. I'm a scientist, so I want to know what I'm dealing with. So I need to know what is smart in the smart city, what is the data, and what I want at the end after this data. There's a very important part here, which is information technology, which is in all parts and all levels of the smart city and the big data, which is not so well known. I mean, lots of people are paying attention to other parts, which are very important also, like statistics and many other, but technology is actually driving all these results to people and to final products. So I think it's good to mention that information technology is playing a main role in all these in order to make things happening. So if we go to more details on this, we will discover that there are different players when you're dealing with big data and smart cities. And some of these players are well known, some others are not so well known. They are having different interests because they are different players, different people acting and working in different places. So you have mostly the university itself creating knowledge and managing things and creating new things, let's say new approaches, new services to, let's say, move forward what we know. There are lots of companies out here. We have some of our colleagues from Airbus and from BT and many other companies here. And this is a very interesting and important part of smart cities also because they are driving also the final application usually. And then you have the city itself, which is the agencies and the departments inside the city who are fostering these kind of services and products. And finally, we have the main goal of smart cities and all we are doing here, which is people. So we are focusing on people. We should be focusing more on people, thinking about them, what they need, and what are they will be focusing in all our applications instead of just stopping in the middle of the change, which is just thinking on the technological part or thinking only in the data. So I think that it's important to have a clear idea that there are many players, that they are interacting in a very conflictive way, usually in most cities of the world, because you know that the interest of the city itself and the companies is not the same. The same happens a little bit for the academy because we want to make science and we want to make something bigger and long-lasting in the future. And then you have citizens who they want just something right now and really good, really cool. So we need to get together, and this is not easy, but it means that if we take into account our players, we can make something if we focus not only on the big data part, but also in the intelligent part. So when you go into the intelligent part, you can find plenty of different kind of things and applications and services. You can find something like apps. Neo, it's the name of my group back in Malaga. So we have lots of Android applications to help regular people. They can be downloaded for free. They will be able of outloading them for free. There are lots of applications in residuals and many other applications in the city for regular people just to impact on them. There are lots of applications in energy because you don't need to think on energy just as a big thing. You need to think in energy at home. How are you saving money because of a more intelligent way of dealing with your energy at home and your appliances and your kind of expenses you're having because of energy. And you're having communications, for example, between cars, which is a thrilling also way for the future, which is generating lots of data and needs something like an intelligent part driving what is happening there in the city. There are lots of applications, and most of them are needed something that people are not talking about, which is software engineering. And software engineering, it's having a lot of importance because it's the soul of what is happening there. People are making applications without lots of standards behind them, without a quality label on them, without using standard practices or best practices for making software. And this is finally in the smart cities and using the big data arriving to final people in your hands, in your cellular phone, in your car. Your car is driven by software. So that's a big issue. You need to ask people to use engineering knowledge for creating software because it's on your demands, it's on your benefit, because you will have safer cars, safer planes, safer homes, and you will live in a better manner if you are taking care of this. And not too many people are talking about the importance of software. Lots of people are talking just on the thing you are seeing there in the room or in the street, which is a nice sensor capturing something, but there are lots of other things happening because you need to take this to other place. You need out of the data to make information, and out of the information you need to make something like knowledge. And in order to go through these three layers, you need to understand that there are many more things and higher level thoughts, especially thinking about how intelligence are the things you're doing. And just to finish, I think that the main point here is that there are many different players and stakeholders in this domain of smart cities and big data. We need to know each other, and we need to work together, and that's the main point I think of any of the presentation that you should be doing in the world, because we need to work together. We need to meet each other, because there's always something important the other guy is having in his head, her head, and we need to know it. We need to interact. We need to make things together, because all these players are having different points of view, and something important and useful will only happen if all these players get together. So that's my final point here. Thank you.
Hello, everybody. My name is Arndt Schirmann. I'm from Airbus Group Innovations. This is the central research organization of the Airbus Group, and I'm working on more industrial or manufacturing topics at the moment. You will see I have a more presentation what is for us as a legacy industry company, let me say, of interest in this topic. I'm not a data scientist. I have colleagues doing that, but I will show you very practical what I have in contact with some problems where I can take this new approaches of big data. So as I said, I'm belonging to this very large European aerospace and defense company, Airbus Group, with some of the products you see here. So very legacy. We're still working on hardware, so we're producing platforms. Some years ago, there was also the trend to go more in services, but we're working on that, but not that ambitious at, don't know, 4 or 5 years ago, when we said 50% of our business has to be services. This was more difficult than expected. So, but around of this product, this hardware products, of course, we see a lot of services you may see as a customer, as a user, let me say, or we have also internal use of big data things. So we are large, and I will give you an example. What is for us big data, or the root of data? Yeah, it's 1 year ago, I remember I was on the Hanover Fair, and there was a speech, very exciting and nice, and this guy said it's time to rethink every business model. So banking is dead because you can do it on your smartphone, and taxi is dead because there's Uber, and hotels are dead because they are Airbnb. But I think we have still the point that some hardware is needed to create what we see as our daily life. And around that, I think we can imagine a lot of things also based on big data, but also other technologies. And you'll see we have a lot of aircraft. This is only the example for the commercial aircrafts. More than 8,000 aircrafts flying around. So if we consider this as a data source, very interesting, you will see later on. And we have a really strong demand. So we have at the moment every year 1,000 and more aircrafts in the order book. And normally we providing something around 600, 650 per year. So there's a gap. We have to increase our production, our rate. And this is something that I'm working on, so more how we can increase our production rate. And there are some aspects also dealing with big data. So our company has identified digitalization as a very important trend also for us. So there are a lot of technologies we are looking at the moment. So I have focused a lot on automation and on Industry 4.0 things, so decision support, manufacturing, and so on. And if you look to big data as one of the technologies out of this digitalization, we can see what is of interest for us as a large industry player. So we have 3 topics. Maybe the most difficult to show an example or to imagine is how we internally organize us. Then we have the improve our internal operations, so manufacturing, all the things. And what you may see more is how we can improve our products and our customer experience, let me say. Can we add some services you may not identify by your own, but they are behind? As an example, if your aircraft arrives in time, sometimes this is because we have added some technologies here in terms of prediction of maintenance needs, fleet management, operations, so that you can fly in the airspace without the delays. In the manufacturing, you will see flight tests is something, a first example I can show you. We have the same in production. If we go to industrialize our production, some hundreds of aircrafts per year, so 60 per month as an example for the short range, so 2 per day. This increase the pressure for us to make it like a car manufacturer. And this creates a lot of data, and maybe we can do something here with this data and the new methods. Or predict upcoming problems with quality, as an example. This is a big topic internally to use this kind of things. Here a small example, what is the new oil? Data is the new oil, maybe. Yes, this is maybe the case, but it's difficult to gain it, to bring it out of the earth and to create some value out of it. And here you see, we have started with a very small aircraft in the 80s with only 12,000 parameters in the flight test, and now with the newest, first commercial flight last year, we have 600,000 parameters in the test. And if you imagine that we're flying this aircraft a lot like our 380s here, we're talking about tremendous amount of data, and the question is, can we gain out of this data some value for internal or for also external additional services? So last slide maybe. We have a clear strategy inside to bring this big data topics into group level priority. So we have a top level approach from our top management, and I'm belonging more to this bottom up. So if I have a good idea, I can raise a hand, request some support, and for the next 6 months I will get some guys to make a study, a kind of sprint, and afterwards we will see then maybe some interesting effects out of big data as an example, technology. And so this is our approach inside of a large legacy company to deal with this new approach of big data or digital. But we can discuss this later on, maybe more.
Okay, so I guess that for the most part, this is an optimistic panel. Okay, so the word smart appears twice in the title. The word quagmire, the word cumbersome, they don't appear. anywhere in the title. So, so this is perhaps a slightly more pessimistic part of the upfront presentation, because data wrangling may be the elephant in the room for big data. Okay, so if big data is the silver lining, then maybe data wrangling is the cloud. So, not in the computing sense of cloud. So, oh, I'm realizing I've skipped a slide. Okay, so data wrangling, what is it then? So data wrangling is what you have to do to the data before you can do analytics. So here's a couple of definitions. First, a process of iterative data exploration and transformation that enables analysis. So the idea, if you like, is that you can't just take the data as it is and necessarily immediately analyze it to get value out of it. And a slightly longer second definition. Process of manually converting a data from one raw format into another format that enables more convenient consumption with the help of semi-automated tools. So here's an indication that there's some effort has to be put into wrangling. That there's maybe tools, but these tools are not going to do everything for you, and therefore probably it is in fact quite expensive to do wrangling. Now, the idea that in order to analyze data, you may need to change its format or pre-manipulate it in some way is not a new thing, okay? So data warehouses, for example, are exactly this kind of thing. And in data warehouses, you take your own transactional database, says you extract some information from that and you put it into some other format for analysis purposes. And because that needs to be done a lot, there are tools that support this. So extract, transform, and load tools do this kind of things. And they support a range of sort of useful workaday tasks like wrapping sources, populating warehouses, and there's normally a workflow language of some sort or other to help you manipulate the data, combine it, clean it, and so on the way in. And ETL vendors quite often have big data offerings, for example, that compile these workflow languages down to run on, say, Hadoop-style backends. So this is all fine, you know, so I'm not here to criticize ETL tools. They're clearly useful. There's lots of vendors, the database companies and integration companies that sell those. But they came from a particular setting, this enterprise setting, which is potentially a reasonably stable setting in which the users of the tools understand the finite number of underlying data sets, and they have a fairly clear idea as to what they're trying to do with the resulting data. But it's still the case that ETL is considered to be very expensive in that setting, okay? So it's often quoted as being up to 80% of the development time in warehousing projects. So that's warehousing, where things are perhaps relatively well understood, and maybe now in big data world we're moving into data lakes and other sort of slightly less well pinned down notions to try to facilitate analysis. So does big data make a difference to these things? So well, here are the four sort of problem big V's, the ones that you need to overcome before you can get to Julia's value big V. So these are the ones you have to contend with: volume, velocity, variety, and veracity. So in this setting, of course, size matters, and it's important to wrangling, but it's not the primary problem for wrangling. Wrangling is faced with the need to try to contend with all of these things at the same time. And the worry here is this classical, substantially manual ETL process may struggle with, for example, enormous numbers of rapidly changing sources. So let me just give a little case study example then. So let's imagine you are an e-commerce company. You're on an e-commerce site, and then you need to be able to understand the pricing trends among your competitors. You know, so here, for example, is a quote from a SME that does e-commerce, sells electronic components, and it boasts on its website that product prices are constantly monitored by active market research to allow them to bring the best deals to you, the customers. But what's involved in that? Well, it's a tricky business, okay, because that involves getting to grips with the data of your competitors, and there may be thousands of those competitors, thousands of different sites. Velocity, all manner of things change all the time. Who your competitors are, how they describe their sites, and so on. The contents change as well. There's variety in the format, the content, the target communities, and so on for those sites, and all sorts of quality problems, unavailability, inconsistent descriptions, and so on. So manual attempts at data wrangling in this context are going to be real hard. So they're likely to be expensive, partial, unreliable, maybe poorly targeted, maybe they're just not looking at quite the right ones, and so on. So data wrangling then is a challenge, okay? It's a research and development challenge. There's not at the moment, though, a well-established community or recognized priorities for this area. So it's quite upstream. The need seems to be great. So here's a quote for data scientists, often spending 50 to 80% of their time on contending with this unruly data. But also I note that the user community might be interesting here. So we've got commercial representation on the panel, all from enormous, well-established organizations. But in fact, this is not necessarily the norm, okay? So here's a UK government survey. 95% of the 120,000 enterprises that consider themselves to be in the information economy business employ fewer than 10 people, okay? So they don't have huge teams necessarily to help them with their wrangling activities. So I just observe, I'm not going to spend a long time drilling in on all of this, that data wrangling may have many different steps to it. So this is not a very sort of simple one-phase process. There's not a fixed data wrangling lifestyle. And these are the kinds of things that you need. But all of these steps have tended to require a significant amount of expert input. And that's what's made the whole process so expensive. So I've just got a list of kind of challenges for data wrangling. I'm not going to zoom in on all of these, but here are the kinds of things that one might have to contend with here. You may need to try to automate as many of these steps as possible, you know, source selection, data transformation, and so on. But when you do automate, you won't get a perfect answer because a lot of these tasks, you know, they were done manually because they were hard. So probably you need to make compromises. So which compromises do you make, okay? So maybe not easy, and you therefore need to make those in some sort of a well-informed way. You probably need some sort of incremental pay-as-you-go approach whereby there's automation to begin with, and then a human comes in, perhaps the end user, to say, no, I'm not really satisfied with this, or I didn't need to know that, and this kind of thing. You need to operate with data that's not just come from your organization, but it's come from outside the organization as well. And also you need to be able to make use of all the available information. And we've maybe got a little bit of a hypothesis here that, that as we move into a situation which there's more and more information available, and some of that can help you to solve problems, whereas previously contending with more data just made things more and more difficult. So anyway, so I'm not going to, of course, tell you how to solve all of these problems, not just because there's only a 5-minute slot, but because I don't really know. But anyway, just to summarize, data wrangling, problem and opportunity. It's a problem because really all those 4 V's may be present a lot of the time, and that's going to get in the way of adding value to data. But it's an opportunity because if we can make significant progress with these sorts of challenges, and all sorts of things that at the moment really are impractical might come into reach.
Hello. All right. Yes, my name is Dale, and as Julie introduced me, I work for IBM. I'm one of the developers of our artificial intelligence platform called Watson. I thought I would bring this section to an optimistic, more positive note at the end. What I thought I would talk about is where I focus is on in applying machine learning and artificial intelligence to big data to try and extract that value that we were talking about before. So what I thought I'd talk about are some of the projects that are good examples of this, some that I've worked on, some that people I know have worked on, but all of which I thought are interesting and might spark some discussion afterwards. So let's start with healthcare. A project from a few years ago now, Seton Healthcare, a hospital we work with in the States. They were interested in their readmission rates. The rates of the numbers of people that after they're treated are sent home only to come back again afterwards with some additional problem, which is bad for the patient. You know, to have to come back again is terrible for them, but also it's bad for the hospital. It's very expensive for them to have to go through the process of discharging and readmitting someone. So what they're interested in is how can they take all that data they have about the patient, everything from the structured data, the readings that were taken, but also all that unstructured data, the text in their medical records and those doctor's notes, and look to spot the patterns of what do these people who come back have in common. And that was a really good example of getting that value from that massive amount of data. There was a number of things that we picked out, some of which are quite dense and medical, but some of which are actually quite obvious when you spot them. So for example, one pattern that we spotted was patients who don't have access to a car or any sort of private transport, and also don't have family who are able to, with access to transport, were more likely to come back. And digging into that, we spotted that it was when their prescription ran out, when the drugs they were given ran out, these were the patients, particularly if they still weren't feeling very well, who weren't able to go and refill that prescription to go and get new drugs. So they got ill again and ended up coming back. So what we did then, with all of these, I think what's interesting is you use the analytics to come up with a theory, a prediction, and then you test that. So what they did was they introduced a program where as they're discharging patients, they ask them, are you going to be able to go and refill the prescription when you run out? Do you have someone who can do that for you? Do you have a car? And if the patients who said no, they don't, they would arrange for nurses to be able to deliver that to them. And then look at, by introducing that, what impact does that have on their readmission rates? Looking closer to home in healthcare, we did some work with a UK health insurer. Now, with insurance, it starts off with you having to disclose the conditions that you have. You have to fill out those endless forms. And then when you get ill, that's when the insurance company actually looks at your medical records. They look at who you are. Because what they're looking for then is to see whether or not they're actually going to cover you. And again, this isn't great for the company, it's not great for the patient. So what we looked at is can we use natural language processing and analytics to try and do that piece up front? Because the reason why they get used to self-disclose with forms is because it's quicker and it's cheaper and it doesn't scale to do it otherwise. But can we use analysis of the text in all of their medical records, everything we can find about the patient, to decide up front if there are any problems? So what we worked on was, well, what if we could say, if this insurance company could say to their customers, when you sign up with us, give us access to all of your medical records. The benefit to you is that we can guarantee that if you get ill, we will definitely cover you, because the onus is on us. If there was a problem in there, we had the chance to spot it up front. So we're not going to say, well, actually, you've got this condition, which means you're not eligible. The benefit for them is that they get to have that discussion up front and not at that painful, difficult time when someone is ill and needs to make a claim. For my work, a lot of the work I've been doing with Watson is to do with oncology, to do with cancer care. And what we've done is looking at using that wealth of literature that's being published, taking the medical research, the doctor's notes, the treatment guidelines, and extracting enough of an understanding of this to support doctors and nurses in the treatment and diagnosis of cancers. And that's now being trialled in a number of hospitals and is showing some really promising results. But it's not just about healthcare. If I look briefly at a few other fields, like we talked about resource efficiency. DeepMind, an AI company in London, they started doing their research using Atari video games, Atari computer games. What they did is they built a system that could learn how to play these games. They didn't tell it ahead of time what the rules were. They didn't tell it how to play. They didn't give strategies. They just let it play and learn from what works and what didn't work, how to play the game. And this system would become a master at these video games. But they were required by Google, and if you look at what Google's been doing with it since, sort of bringing it to the real world, some really fascinating applications. Even internally, they've been trialing it on managing their data centers. Because there's lots you can control in a data center, the fans, the cooling systems. And they've basically let DeepMind play this like a video game. What can they control? What can they change? And what impact does that have on their energy usage? And now with DeepMind managing this, their initial studies show a reduction in electricity usage of something like 15%, which when you're talking about the amount of energy used in a Google data center, that's huge. What else should I talk about? Financial services. We work with a lot of banks, a lot of insurance companies. There's lots of case studies of this being used in a sort of recommendation system kind of way, borrowing from the retail model of customers like you have got this, and showing real improvements in sales, both in terms of targeting the right products to the right customers, but also offering it in the right way. Some of the more interesting projects, though, have been around spotting when their existing customers get into trouble. Can you identify from all the transaction data, the massive amount of transaction data and personal data they have about each of their customers, can they spot patterns and trends in the customers who are going to get into trouble, the ones who are going to default on their loans? One retail bank, one of the patterns they spotted that was quite interesting was for this group of customers who are more likely to default on loans, default on payments, this was preceded by an increase in the number of times they made credit card payments at night instead of during the day. And this, along with a ton of other factors that they noticed. Basically, what they were spotting was factors that indicated stress. When people getting stressed got more likely to get into financial difficulties, more likely to end up then defaulting on their loans. So having identified this series of factors that indicated this sort of collection of stress and difficulty, they're then now reaching out to those customers ahead of time, adjusting credit limits, offering them financial support, offering them advice and how to manage their finances before they get into that sort of deep problem. I've run out of time, so I haven't got time to talk about it anymore, but there's lots of these kinds of things that can really address that kind of value idea of how can we spot patterns, and how can we use that insight into massive amounts of data to help. Thank you.